Hey, Miss Parks.
Sorry, I had myself muted.
No, it's okay.
All right, how are you?
I'm good. How are you?
I'm doing good. I used this worksheet last year, so I had to go back in and erase some of my stuff
I got you.
so we could start over. Do you want me to start with number one, or you feel pretty good about these?
I think if we just started and just went through it, that'd be great.
Okay. All right. So negative 100. So basically, we're making circles.
Okay.
And when you're going in the negative direction on this, you're going clockwise. Okay. So like when you go positive, you go this way. All right.
Okay.
So this is negative 100. So we're going to start and go this way. Okay.
Yes, ma'am.
So when we hit here, since this is a right angle, how many degrees would that be?
Uh, 90 or
90.
45.
Good
45.
job.
Oh, it is 90?
90 degrees. So we're going to go just about 10 more. Not looking for exact here, but it's roughly 10 more in my world.
Okay.
And so you'll draw that angle right there. And then you have to also draw this goofy little line right here that's kind of your directional arrow. And I'll make mine green because that indicates that you're going negative. Does that make sense?
Yes,
So you've
ma'am.
got one arrow that kind of indicates the degree position, and you've got one arrow that's your directional.
Okay, so all we're doing for this really is just showing where the angle is, basically.
Yes, sir. That's it. And 40 is a little less than half of 90. So for this one, and it's positive. So we're gonna this quadrant right here, we're gonna kind of split a little less. So to me, that's roughly 40. And then my directional arrow is going to be that.
Okay.
Okay. So 230. We're going in the counterclockwise direction. And if I make it all the way over to here, that's 180. And I'm going to go about 50 past that. So a little beyond splitting this one. It's a little bigger than that. And so then I've got to include my directional arrow. So there's 230.
Okay.
Okay.
Yes, ma'am.
All right. Now for radians. First of all, once again, with the directional, it's the same exact thing as the degrees. And so what I'm going to do on this fractions, I know how you guys love fractions,
Oh,
but I want to kind of think about it from a fractional standpoint, if you will. If I went all the way over to here, I know that's pi, right?
Yes, ma'am.
So if I was stating that in a fraction, that would be 18 over 18, 18 pi over 18, right?
Yes, ma'am.
So right here is going to be roughly 9 pi over 18 because that's about halfway if I'm just dealing with this quadrant. Technically, it's a little more than that. It's actually 9 plus 18, which is 27. Right?
Mm-hmm.
27 pi over 18. All right. So each one of these is about 9. I mean, like roughly the value. So this is going to be itty bitty. Okay? And we're
Okay.
going backwards.
Okay.
It's probably even smaller than that if you could make it smaller on your paper. Because there is going to be 9 of these between here and here and then here and here. Does that make sense? So that's you'd be like if I said, okay, Braden, we're gonna cut this little quadrant into 9 sections. So that'd be half, and then you'd have to do a whole bunch of these little things. Does that make sense?
Yes, ma'am.
Those look like capillaries.
They do.
So it's itty bitty right there. And then my directional arrow is going to be this way because it's negative. All right.
Yes, ma'am.
Does that kind of make sense?
Oh, yes, ma'am. Kinda.
Kind of, sort of.
Yes, ma'am.
Since, you know, as much as a fraction can make sense.
Yeah.
You could convert that to degrees if you wanted to. The downside to that is I don't always want to get y'all into a habit of converting to degrees, because if you're asked a question in radians, you need to give the answer in radians.
Okay.
So that's why I don't always want to be your first impulse is to convert.
Yes, ma'am.
All right, this 5 pi over 3, that should be a little familiar to you because that's one of the hot spots on the unit circle. And it's a little more than, you know, your 3 pi over 2, which is down here. Oh, it's not writing. 3 pi over 2. It's a little more than that. It's this mark right here. Right where the 300 mark is.
Okay.
It's 5 pi over 3. So your directional then would be this.
Okay. Cool.
All right. Oh, there's all my work.
Oh, wow.
Yeah. That's from last year.
Oh, it looks like this will be fun then.
It is. But do you have your calculator? Because I want to make sure I give you the trick.
Okay.
I may have to. Sometimes my computer starts to lock up if I erase too much. So I think I'm going to try to erase a little by little.
Okay.
And so hopefully my other work won't jack you up too bad, you know?
Yes, ma'am.
All right. Because when we get to the radians, I want to remind you of the trick. The trick. And then, plus, you're always my calculator guy. Although I have my own calculator now. Yay! I just have to find it. Okay. We're going to find a positive and a negative coterminal angle for each given angle.
Okay.
Okay?
Yes,
so
ma'am.
What we're going to do, a coterminal angle just means it's going to be multiples of 360 away from that 90. So to find a positive angle, I would add 360 to 90. And that's going to give me, what, 270? Is that right?
Yeah, I believe so. Yes.
Yay, 270. All right, so there's our positive. And for our negative, I'm going to subtract 360. So that's going to give me 450, negative 450, right?
Mm-hmm.
So we're done.
Yeah.
All right.
So we could come to math lab and it's this easy, you know?
Oh, God love you. Hey, you know what? Don't feel too bad because, you know, here's the thing. We learned so many different concepts in this trig unit.
That's why I get so confused.
Well, yeah, that's what I was to say. It's just like, okay, what, and on top of it, it's a lot of new vocabulary. I mean, like,
yeah,
you know, coterminal and terminal, and, you know, and then we're adding radians, and like, you're like, Miss Sparks, what language are you even speaking right now? So, I mean, I get it. You know, all this stuff, this isn't your typical math vocabulary. You know what I'm saying?
Yes, ma'am. See, I'm good
So
with the, adding, subtracting, multiplying, dividing. That's where I'm good at.
yeah, like you start throwing in coterminal and net and all those other verbiages. Okay, so for number 7, once again, it's pretty easy. Just going to add 360 to negative 346, and that'll give us our positive angle of 14 degrees. And then if we subtract 360 from this, that's going to give us 706 degrees for our negative.
So is that what you do for all of these, except for the ones with like the
With the
radian?
radians, it's going to be a little bit different. And I'm going to
Um,
give you the calculator trick on this. And hopefully it will stick in your sweet little brain, for tests and et cetera. You know what I mean?
yes, ma'am.
So this is what I would do for number 8, though, is subtract 360 to get my positive angle, because that's going to give me 110. And then I would subtract 720, or you could subtract 360 from this. Either way you want to do it.
Wait, why like I'm kind of confused. Like why don't you just do the add 360, subtract 360? Like, what's the difference between it? Is it
Okay.
just 'cause it's greater? If it's a greater number than
Yeah. So
360?
I could have just added, I literally could have added 360 to it also. I could have, which is perfectly fine. 0, 3, what is that? 830? Okay,
Yes,
because that
ma'am.
is a positive coterminal angle. But I just chose to subtract 360 because it's greater than 470. And then if I subtract 360 again, I'm going to get negative 250. Or I could subtract a multiple of 360, which is 720, and get my negative 250. Because I know if I subtract just 360, I'm still going to end up with a positive coterminal. And I'm looking for one positive and one negative.
Okay.
And so I got 110 and negative 250. But 830 is also an acceptable answer. Does that
Okay.
make sense?
Yes, ma'am.
Okay. When that number is bigger than your 360, you have to kind of loop around again.
Yeah.
And that's going to be true in radians as well. When you have a radian measure that's bigger than 2 pi,
Okay.
you would have to loop a couple of times.
Yes, ma'am.
All right. So 2 pi is the equivalent of 360. That's really a good thing to kind of really memorize, keep in mind. What is the radian equivalent of 360? And that is 2 pi.
Okay.
So basically what we're doing here is we're adding 2 pi, just like we added 360 over there. Okay?
Yes, ma'am.
Now, here is the calculator trick.
Okay.
Okay?
Yes, ma'am.
3/4. No, I'm sorry. I already messed you up. Ignore the man behind the curtain. Okay. Let me just do this on my calculator to make sure I don't tell you something incorrect.
Okay.
All right. 3 divided by 4
Yes, ma'am.
math, enter, enter.
It's
Now plus 2.
2.75.
Oh, really?
Yeah.
Ugh. You did 3/4.
When I do math, enter, it's fraction.
Yes. It should and did you hit +2?
Yeah.
And did it say answer +2?
No, I'll do it again. Hold on. 3 divided by 4.
Uh-huh.
Math, fraction, enter. 3 divided by 4, still. It's 3/4. Then you gotta do +2.
Yeah, just hit +2.
Yeah.
Does
2
it say
point.
answer +2?
Yes, ma'am.
It does?
Yeah.
And it gave you 2.75?
Yes, ma'am.
All right, hit math, enter then, and see what happens.
Okay. 11/4.
Yep. And that's your answer.
Okay, so that's a good thing that I got 2.75.
Well, yeah, 2.75 is the correct answer in decimals, but I'm trying to figure out how we can get yours to 3 divided by 4. Let me try something. 3 divided by 4. Let me try something on my calculator to see if it works.
Okay.
All right, try this. You ready?
Yes, ma'am.
Open parentheses,
Yep.
3 divided by 4, close parentheses, +2, math, enter.
11/4.
Okay, so your answer is 11 pi over 4.
Okay.
But you have to remember to put that pi back in there.
All right.
Now, if you didn't have a fancy schmancy calculator, you would have to convert 2 pi over 1 to an equivalent fraction to add to that. So 2 pi over 1 is the same as 8 pi over 4. Now I have a common denominator, so I get 11 pi over 4. Either way is correct, but you're always adding 2 pi. But when you add fractions, they have to have a common denominator, right?
Yes, ma'am.
So this is the old-fashioned way to do it, right here. And the way on your calculator that I just showed you. Now you want to do it again. Okay, that's the 3/4. Now we're going to do 3/4 minus 2, math, enter. And tell me what you get.
Hold on one sec. And do -5/4.
That's right. That's what I got too.
Okay.
Doing it the old-fashioned way, because I basically just took this 8 pi over 4 and subtracted it from 3 pi over 4.
Okay.
Does that make sense?
Yes,
So
ma'am.
either way you want to do it. You can do it the old-fashioned, oh my gosh, it's a fraction, Miss Sparks way, or you can do math, enter.
I like doing the math enter way.
Okay, so basically the same exact problem, except now you have a negative. So you would want to do open parentheses,
Okay.
-3 divided by 4, close parentheses, +2, math, enter.
5/4.
That's correct. And now you want to do open parentheses, -3 divided by 4, close parentheses, minus 2.
Wait, negative 3 pi over 4?
Well, you don't have to do the pi. Not when you're doing the math enter thing.
Okay.
You don't have to do that part. You just have to remember to add pi at the end.
Yes,
I
ma'am.
show all of my work when I'm doing it the old-fashioned, fangled way.
I got you.
But you would only have to do open parentheses, negative 3 divided by 4, close parentheses, minus 2, math, enter.
Yeah. So I got 5 pi over 4 and negative 11 pi over 4.
Right. And it's just the exact opposite of what number 9 is.
Yeah.
So cool.
Mm-hmm.
All right.
I
So
always
now,
have trouble with these.
okay. This is converting, and you're going to do a lot of this next year in chemistry. And you probably did a little bit last year with Miss Wren in physical science.
Oh, yeah, we did.
When you're doing conversions, the biggest thing to remember is what you're trying to get rid of, you want in the denominator, and what you're trying to go to is in the numerator.
Okay.
So, and you always use the same ratio. It just, that ratio is, it's the ratio is the same in that it's going to be pi over 180, or it's going to be 180 over pi. Same ratio, except the inverses of each other, basically. So what do we have on top here? On number 11.
13 pi.
Right. So that's radians. And we want to convert to degrees. So you would want radians to be in the denominator. What you're trying to get rid of, you want in the denominator. What you're trying to go to, you want in the numerator. And the reason for that is, remember, when you multiply fractions, you can simplify before you multiply, which means these pi's are going to cancel out.
Why is it that you have 180 over pi? Like, how'd you know that was your...
That is, you know how there's always those units of conversion?
Yeah.
You know, like there's 3 feet to a yard, and there's 12 inches to a, so like if I'm converting inches to feet, the ratio that I would do is 12 inches to 12 inches to 1 foot. Oops, I was thinking yards. And so, right?
Yeah.
That's how I know. I know there's 180 degrees in a pi radian, just like I know there's 12 inches in 1 foot.
Yeah.
You know, when we do our unit circle,
yes, ma'am.
and you get over to the other side, and I'm going to go over the unit circle here in just a minute, but when we're doing that unit circle and we go over to here and you filled out all those things and you get over here, it's 180 degrees, but it's also pi.
Yes, ma'am.
That's because they're the same.
Okay.
And 2 pi, great question though. Great question. And 2 pi is 360. They're the equivalent of each other. Just like when we were trying to find coterminal angles, and we would use 360 when we used degrees, and we would use 2 pi when we used radians. Yeah. So 108, 2 180s is 360, and 2 pi is 2 pi. So that means half of that. When you're converting, you only have to use half of it.
Okay.
And that's because, you know, basically if I have 360 over 2 pi, which though that's an equivalent ratio also, that can be reduced to 180 over pi. And that's the reason for that.
Okay.
Okay.
Yes,
hopefully that helps a little bit.
Yeah.
So simplify before you multiply. That means our pi's cancel, but it also means we have the opportunity to make this a little smaller. 9 goes into 9 one time, and 9 goes into 180 20 times. So now 20 times 13 is 260.
Okay.
So it's 260 degrees. So now converting from degrees to radians, I want my degrees on the bottom. So the 180 is going to be on the bottom. And I want my pi on top. So now my degrees are going to cancel. Does that make sense? This little degree symbol cancels.
Yeah.
And so I believe 15 goes into 165. It also goes into 180. I can't think of anything else smaller than that.
Okay.
Or bigger than that. So 15 goes into 165 11 times. 15 goes into 180 12 times. So we have 11 pi over 12.
Cool.
All right.
Yes,
So
ma'am.
we're trying to get degrees again. So we want degrees for our ratio to be on the bottom and pi to be on top. 10 goes into both 130 and 180. This is 13. This is 18. So this is 13 pi over 18. Is this making a little more sense?
Yes, ma'am.
All right, good. So once again, converting from degrees to radians. So I want my degrees on bottom and my pi on top, or my radians on top. And I'm looking for how I can simplify this. 30 goes into both of them. 30 goes into negative 330 11 times. And 30 goes into 180 6 times. So this is going to give me negative 11 pi over 6. So on number 15, which ratio am I going to use?
The pi over 180.
Perfect. You're a genius.
Not really. Thank you.
You are. There you go. You're doing great.
Thank you, Miss Sparks.
All right. So let's see. Trying to think of the biggest number that goes into both of them to get this reduced. I believe it's 20. 20 goes into 280, and it's going to leave me 14. And 20 goes into 180 9 times. So we'll get 14 pi over 9.
Okay.
All right, number 16, which ratio am I going to use?
You're going to use 180 over pi.
180 over pi. Good job. Genius. That way our pi's cancel. And let's see, we discovered earlier that 12 goes into 180 15 times. Don't forget your negative over here. So that's negative 1. So negative 1 times 15 is negative 15 degrees. I should add a little degree symbol there on my 180. Okay, which one are we going to use for number 17?
We're going to use pi over 180.
Perfect. You're rocking this.
Thank you, Miss Parks.
All right, 50. Let's see what's going to go into both of those. 10. So negative 5 and 18. So negative 5 pi over 18. And number 18, I'm going to use what?
Pi over, 180 over pi, my bad.
Good job. That's it. So the pi's cancel. And then 18 goes into itself 1 time, and 18 goes into 180 10 times. And negative 73 times 10 is negative 730 degrees. And number 19, we're going to use 180 over pi. Pi's cancel. 6 goes into itself 1 time. Goes into 180 30 times. And 30 times negative 11 is negative 330 degrees. And the last one, we're going to use 180 over pi. Again, the pi's will cancel. 18 goes into itself 1 time. 18 goes into 180 10 times. And 10 times 37 is 370 degrees. And my hope on this was just to have everybody kind of really have enough practice, simple practice, to be like, okay, which ratio am I going to use? And just remember to simplify before you multiply. That was the big reason for this particular worksheet, because I feel like some of these smaller principles get lost in the bigger things that we're doing, like angle of elevation and finding the 6 trigonometric functions. And these are some of those smaller concepts, but very crucial in trig. Yeah. So that's why I felt like a lot of, kind of rote, simple practice would be helpful in making those concepts stick. That was my hope. I wanted to, if you want me to go over the unit circle to kind of help you with the coordinates for tomorrow's quiz.
Sure.
Okay. That was the next thing that I was wanting to do in math lab today. So. Okay, so just kind of to review the degrees, just remember that you start at 0. Let me change my color since that's already. You start at 0 and you end at 360. So that's why there's 2 of those. And when you're given the radians, you start at 0 and you end with 2 pi. Because those are those equivalents. And then over here, and then, so that's why there's, a set above, that's kind of your starting point, and this is your ending point. So that's why on the unit circle quiz, there's a place at the start and there's a place at the end, but it's still basically right over here on the x-axis of the unit circle. Does that make sense?
Yes, ma'am.
Okay, so that's why those 2 blanks. And then there's a big jump from here to here, and that's like that double 15, and you start at 30. And then you go increments of 15 until you hit this point, which then from 60 to 90, you have that big 30 jump.
Yes, ma'am.
And then another 30 jump, and then your 15s, and you go around like that all the way back to 360. Just kind of a review for the degree portion. Now, if the other way to think about radians is if you're not a person that likes to break it down into the 12s and the 6s, which I get that. Not everybody is that. I shared in class, my sweet nephew memorized the fact that it actually is it's the denominator go in a pattern of 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. So he basically goes in and fills all his denominators in first.
That's what I tried to do yesterday, and then I like forgot the numerators, and I was like, poop.
Okay, that's cool. Well, you got that part. So then what he does is there's nothing on the first 6, 4, 3. So you know you got those all right, right?
Yeah.
Oh, and then we'll go back to the quadrantal angles for the radians in a minute. So what he did, because you guys are really good at phone numbers, he looked at it like a phone number and he memorized it. It's 235 754 5711. It's a phone number.
2, 3, 5, 7, 5, 4, 3, 5.
5711. 5711.
Wait, so they did 2, 3, 5, 7, 5, 4, 5, 7, 11.
Yep. And the 11 goes on 1. So we did 2, 3, 5, 7, 5, 4, 57, 11. And that's just a phone number.
Okay.
So I don't know if that helps. That's just another way to memorize it.
Yeah.
If you're more of a phone number kind of guy, then I'd go with that. And he is. So that's what he told me that he did. And I thought, I'm going to share that with the class. Because, I think he was visiting me last year when I was teaching the unit circle. And he says, the unit circle. Everybody's favorite.
Yeah,
All right. So your quadrantal angles, remember you've got 0, just like your 0 degrees. And then you've got just regular pi, because this is pi over 180, your whole conversion. Remember the conversion ratio?
Mm-hmm.
And then over here at 360, 180, 360 is 2 180s. So all you do is add the 2 in front of the pi for over here on this quadrantal angle. Okay?
Yes, ma'am.
And here, it's half of pi. You cut the pi in half for the top. And then you have 3 halves of the pi down here. Because you've got 3 of these sections. By the time you get to here, you've got 3 of these. Does that make sense?
Mm-hmm.
So that's how you memorize the quadrantal ones for the radians. Did that help a little?
Yes, ma'am.
Okay, cool. All right, now the good old coordinates.
So, wait, really quick though. On
Okay.
my 270 degree, I have 3 pi over 3.
It's 3 pi over 2.
Okay, so I was wrong.
It's 3 pi over 2. All right. Are you ready for me to move on to the coordinates? I don't want to jump ahead of you till you're trying to. Okay.
Good.
All right. So let's talk about the quadrantal coordinates first. Let's not forget that the unit circle is what it is, because basically this is just like if you are looking at the coordinate plane, all right, and this is the origin, okay?
Mm-hmm.
The unit circle is just over 1 in every direction. That's why it's called the unit circle.
Okay.
Okay? Not a horrible circle there. So if this is the origin on the coordinate plane and I only go to here, my x would be 1 and my y would be 0 because I went over 1, but I didn't go up any.
Correct.
So that's why that coordinate is what it is.
Yeah.
Okay. Up here, I would have gone over none, but up 1. And over here, I would have gone left 1, but up none. And down here, I would have gone down 1, but over none.
Mm-hmm.
So that's how you get the coordinates for the quadrantal sections. Does that make sense?
Yes, ma'am.
All right. Now the funky ones.
Mm.
Do you remember way back when we talked about 30, 60, 90 triangles? The very first.
Kinda.
Well, this is a 30, 60, 90 triangle. And this theta angle right here is 30. And that's why we have this measure here.
Mm.
And if you'll remember, this radian measure is going to be 1, right? Because it's the unit circle. So my hypotenuse is 1. And I don't know if you remember this or not, but we had a particular ratio that we used every single time for those 30, 60, 90 triangles. And it was x and then x root 3 and then 2x. Do you remember that vaguely?
Well, yeah, we just went over that.
Right. And this was, yep, and that's the short leg. That's the long leg. So what I know is that my 2x is 1. So if 2x equals 1, then x equals 1/2. But in this case, it's the short leg, which is over here, and this over here is the long leg. I don't know if that makes sense to you or not, but that's why this is the way it is. Because it's a 30, 60, 90 triangle. That kind of proves why it is the way it is. But what I want you to notice is that then this is the 45, 45, 90 triangle, and those sides were the same on a 45, 45, 90 triangle. Those sides were the same. So you'll notice the x and the y coordinate are the same. And what you'll notice up here is that this is a 30, 60, 90 triangle as well, but your x's and your y's are flip-flop because this will be, the x will now be the short leg and the y will be the long leg. So these two right here have the same values except they're flip-flop for the x and the y. Right?
Yeah.
And these two are the exact same. So if you will kind of memorize these three, these are the primary ones. Because once you move over here to this quadrant, this is the exact same thing.
Just in negatives.
But the x is negative because obviously x is negative over here on this side. The x is negative here and here because all x's are negative, but y's are positive. And down here in this quadrant, both same exact thing. It's going to correspond, right?
Yeah.
But this is going to be all they're going to be negative. Down here, x's will be positive, y's will be negative because down here in this quadrant over here, x is positive and y is negative. X is positive. And we kind of talked about that when we talked about sine and cosine too. But basically, if you can get these 3 sets of coordinates memorized, they just transfer to all 3 quadrants, but they have differing signs based on where they are on the coordinate plane and what quadrant they're in.
Yeah.
Does that help a little?
Yeah, that does help make more sense.
Okay. And if you've made your unit circle folder, that's why those little triangles are on there, to kind of try to help you with knowing those sides.
Yeah, I realized that as you were talking. I looked over my unit circle folder and I was like, hey, that's probably
Yay! Good. I love it when there's connections. That's such a huge blessing. All right. Do you have any other questions for me?
I do not think so. I appreciate it, Ms. Sparks.
Oh, not a problem at all. Just email me if you have anything else, okay?
Okay, thank you. Have a good
All
day.
right. All right. You have a blessed day, sweetie.
Bye.
Bye-bye.